Good morning, students. Today we are going to see about the introduction of 8085 microprocessor. And before we see about 8085 microprocessor, let us recall about what is microprocessor. A microprocessor is a multi-purpose programmable logic device that reads the special binary numbers of zeros and ones, and it processes the information. And it is a programmable device that accepts the digital input and process it according to the instructions stored in the memory and provides the result as an output. That is said to be your microprocessor. And this is a basic block diagram of your microprocessor, and where you have input and output and I/O ports, and CPU is the main central processing unit of the entire system, where all input and output performance are made. And it has various buses, that is data buses and address buses for communication between the devices, and it has a memory for a storage purpose. And let us see about 8085 microprocessor. So 8085 microprocessor is designed by Intel in 1977 using NMOS technology, and it is an 8-bit data bus, and it has a 16-bit address bus where you can address up to 16 kilobyte of data, and it has 16-bit program counter and a 16-bit stack pointer, and you have a 6 8-bit registers that is paired as B, C, D, E and HL, and it requires a power supply of 5 volt, and it operates at 3.2 megahertz of frequency, and in hand it has various serial input and output ports. Okay, and next let us see about the architecture of 8085 microprocessor. So the architecture mainly consists of an accumulator. It stores an 8-bit register. It is used to perform all arithmetic logic and input output operation, and as well as load and store operation, and it is connected to the internal database and ALU. And next is your arithmetic and logic unit. It performs all arithmetic and logical operations such as addition, subtraction, and or etc., and it is performed by 8-bit data. Okay, next you have a general purpose register in the right side. So there are 6 general purpose register in 8085 processor. They are B, C, represented as B, C, D, E and H and L. Each register hold an 8-bit data, and these register can also work parallelly to hold 16-bit data by pairing as B, C, D, E and H, L. Next is your program counter. It is a 16-bit register used to store a memory address location of next instruction to be executed, and microprocessor incremented the program counter wherever an instruction is being executed, so that the program counter points the memory to address the next instruction that is going to be executed. And next is your stack pointer. It is also a 16-bit register, works like a stack, which is always incremented or decremented by 2 by with push and pop operation. Okay, next is your temporary register. So it is an 8-bit register which holds the temporary data of all arithmetic and logical operation. Next we go for a flag register. It is an 8-bit register having a 5 1-bit flip-flop which holds either 1 or 0 depending upon the result is stored in the accumulator. So there are 5 flag register. One is your sign register, and other one is your 0 flag. Next one is your auxiliary carry, and next is your parity, and last one is your carry flag. So let us see about the flag register. So this is a register organization where you have a B, C, D, E and H and L. They can be paired to store the 16-bit of operation, and your 60 stack pointer and program counter, or where you can perform 16-bit of operation, and you have the 8 bidirectional line and 16 unidirectional address space. Okay, and next is your register. Okay, so you have a 5 register where S represents your sign flag is set when the result of the operation is negative, and next is 0 flag. This is set when the result of the operation is 0, and next is your AC is your auxiliary carry. This flag is set when the carry out of the lower nibble or lower 4 bits of the operation, And CY is your carry flag is set whenever there is a carry is generated by the operation. And next is your parity flag is set when the result contains even number of ones and reset X, that is don't care flip-flops. And 8085 uses these flags registers for decision making. And so this is a basic about the architecture of 8085, and these are the few assessment questions. You just try to solve it, and if you have any clarification, just contact me. And thank you.